Welcome to qnawire.
Okay, so we have 9 electrons in fluorine, and we've been asked to kind of fill out this table. And I think what's important is to just, kind of build this up. Before we look at the table, just remember that we're basically saying that fluorine has, 1s2, 2s2, okay, and then 3p5. Sorry, 2p5. Right. So this is the sort of simplified electron configuration that we might expect for fluorine. Okay. And now we can kind of step through this and say, okay, so for our electrons, we're going to have N, we're going to have L, we're going to have M sub L, and we're going to have M sub S. And I guess, orbital will be like, S or P or what have you, right? Okay, so initially we're going to look at N, right? And N in case of this picture is really just the number. N is 1, okay? And L, when we have N equals 1, can only be N minus 1 or 0, okay? And then we know that M sub L can range from negative L to positive L. Well, if L is 0, M sub L can only ever be 0. But M sub S, right? Here is where for any given orbital and suborbital, as we get into L and M sub L, we can have spin up or spin down, meaning positive 1/2 or negative 1/2, right? And this is an s orbital. And so the next electron, right, the second in this 1s orbital must be exactly the same, but negative 1/2, right? 1, 0, 0, negative 1/2, okay? Okay, then we move on to 2s, right? So for a 2s orbital, right, n equals 2, right? But it's not a p orbital, right? Right. Remember, our options now become L equals negative 1, 0, or 1. Well, negative 1 or 1 are p orbitals. We're still s, meaning L is still equal to 0, meaning M sub L is still equal to 0, and M sub S can take on being either positive 1/2, right? Or for the second electron in that S shell, negative 1/2. Okay, so there's the first 4. It's 1s, 2s. Okay, now we move into the P, right? And so here, N is still 2, right? But suddenly L becomes 1, right? Because L can range from 0 all the way up to n minus 1. Okay, so previously when n was 1, the only option for L was 0. And then when n was 2, we can have 0, which we did, or 1. And now that L is 1, M sub L can range from negative 1 to 0 to 1. Sorry, this is M sub L, not L. Okay. Right. And we've taken care of well, what we've got to take care of first is M sub L equaling negative 1. We could start on any of them. It's arbitrary, but we're going to do negative 1 first. Okay. And then, again, there can be 2 electrons with this particular signature. We can have the positive 1/2. This is now P. Or we can have the negative 1/2, right? But these will remain the same. Again, P. Now still within the same shell and subshell, but now moving to L equals 0. We get M sub L equal to 0. Sorry, I'm messing this up. L still equal to 1, but M sub L now equal to 0. We again have 2 electrons in here, positive 1/2 and negative 1/2. Okay, but now we finally get to our final electron. Now there's room for 2 electrons in this shell, but we only have 1. Right? But our M sub L goes to positive 1. And then we can just pick here positive 1 or negative 1. I'm just going to do positive 1. Right? So this is the 9 electrons in fluorine in the ground state.